Good morning, everyone, and a very warm welcome to all of you. I am Dr. Alejandra Fernandez, a Science and Technology Policy Analyst here at the Australian Academy of Technological Sciences and Engineering, also known as ATSE. I'd like to begin by acknowledging the traditional owners of the lands from where I am joining from today, the Ngunnawal people, and pay my respects to their elders, past and present. I would like to extend that respect to any Aboriginal or Torres Strait Islander people joining us today, as well as to acknowledge the traditional owners of whatever country you are joining us from today. As we come together to share and discuss our knowledge and experience, we also recognize the traditional knowledge and the deep history of Australia's First Peoples as the world's oldest surviving culture and Australia's first scientists and technologists. Before we get on to today's webinar, I just want to start with a little bit of housekeeping. We would like to remind all attendees that they have agreed to abide by ATSE's Code of Conduct, including as you enter your questions into the Q&A channel. This webinar will be recorded and the recording will be made available on ATSE's YouTube channel shortly after today's session. We are also happy to send that link through to all registrants. Captions are enabled today, so if you require them, they should pop up at the bottom of your screen. As the session progresses, the feedback surveys will be shared in that chat. Please take a moment to complete them. We are keen for this to be an interactive session, so please be sure to submit your questions in the Q&A box at the bottom of the screen at any point throughout the webinar. Before I hand over to today's moderator and our brilliant panelists, I thought I'd share a little bit about me. As I said, my name is Dr. Alejandra Fernandez. I initially did a Bachelor in Science where I majored in biochemistry and molecular biology. And then I did an honors year where I focused on the chemical properties and therapeutical properties of plants and look at their potential role as therapeutics for autoimmune diseases. And recently I finished my PhD, which was more focused in cancer cell biology, where I studied a protein known as retinoblastoma binding protein 7, or RBBP7 for short. And I studied its role in repairing DNA. And also I studied to look at this protein to see if it could be used as a target to use as a therapeutic for lung cancer. So this wonderful webinar series is brought to you by ATSE's National STEM Education Initiative, Stellar, which is designed to engage young people in rich STEM learning at school by using hands-on, curriculum-aligned resources to explore the principles of sustainability and renewable energy. We have over 280 lessons and over 100 hands-on activities for use in the classroom. And you can find out more by visiting stellar.org.au. The theme for today's session is Molecules to Machines, Chemistry Links to Careers in STEM. It is an exciting chance for us to explore how the fundamental science of chemistry underpins a vast array of exciting STEM careers, from designing innovative materials to revolutionizing medicine and beyond. With that, it is now my absolute pleasure to introduce you to our first speaker and ATSE Fellow, Professor Michael Bretmore.
Good morning, everyone. As you just heard, my name's Michael Yarpalingana. I'm currently in Nipaluna, which is the city of Hobart, in Lutruwita, which is the state of Tasmania. And I acknowledge the traditional owners and custodians of the land of which I live and work on, the Muinana people. I also want to acknowledge, given that this is a STEM session, the unique place that the Indigenous peoples of Australia have had in science and engineering and technology that spanned thousands of years, and the maintenance and transfer of that knowledge through their traditional practices down through today has a significant impact on what we do. I want to welcome you all here, whether you're a student, whether you're an educator, whether you're someone in the public who's just interested in about chemistry and molecules and materials and what we can do with them. It's wonderful to have you all here. I'm also going to preface this by saying there's no such thing as a dumb question. The only dumb question is the one that is not asked. You are all anonymous, so please ask all your dumb questions today. We will give you equally not dumb answers to the best of our abilities, and hopefully we can make this an engaging and informative process for you all. Chemistry spans the whole range of things from molecules right through to complex machinery, and even now molecular machines and nanorobots, and the things that we are starting to be able to do are really quite exciting and sometimes a little bit scary when you think about it. I don't know whether you're a Star Trek fan like me, but pictures of the Borg gave my son nightmares of artificial intelligence and machinery interface with humans. That kind of thing is coming, and it's going to be coming here very soon, and chemistry has a really significant role to play in that. Energy, manufacturing, health, it's all really fundamentally depends on chemistry. So there's a heap of opportunities, there's a heap of careers. You're going to hear from a few options today, but there's so many more. And if you have some questions about those, please feel free to ask. I'm really excited to be here today with our two other panelists, Amina Hassavand and Vanessa Yolanda, and they're going to share their journey and their experiences in chemistry and perhaps even beyond chemistry into what they're doing now. But before I introduce them, I'm going to tell you a little bit about myself. So you already know that I'm in Tasmania. I'm actually Tasmanian. I was born here. And you might see that world map. This is the journey of my career. I was born in Launceston, actually, but I lived in a small town on the northeast coast of Tasmania called Bridport. You can see that in the picture there. It's a nice sandy beach by the ocean. And I had a great life growing up by the beach. I went to school during the winter. I played football, and the summer was fishing and swimming and spending as much time outside of the beach as I could. I think it was about the age of 10, I decided that I was going to be a marine biologist because I love the ocean, I love fishing. That actually didn't happen for various reasons, some of which was that when I went to high school, I discovered that I was relatively good at maths. Math was relatively easy to me. And so my dad at that point said that I should become an accountant because, they're good at maths. I didn't really like the prospect of becoming an accountant, and I didn't do that. But I did become a scientist, and I moved down to Hobart to do my undergraduate degree in science and law. I wasn't quite sure whether I wanted to be a scientist at that point in time, so I decided to explore the field of law, and I found that to be quite fascinating. With the ability to think logically as a scientist is actually really useful in a legal context when you're constructing legal arguments. But after a couple of years of law, I really decided that that really wasn't my passion, and I moved into chemistry because I really loved doing experiments. And there was one particular experiment where we were given a chemical, and we were made to find a chemical reaction from the literature and to do that with this chemical. And the chemical that I picked and the reaction I picked had never been done by anyone in the world. And that was really exciting, to do something that had never been done by anyone in the world, or at least never reported by anyone in the world. It didn't work particularly well, but it was that prospect of discovery that really got me engaged in science. And so I then decided at that point that I would do a PhD. I did a PhD here at the University of Tasmania, and so that's me in the bottom corner there with my funny hat and my gown when I graduated with my PhD in 2001. And from that point, I began my journey around the world. I got to spend a year at the University of Virginia, just outside of Washington, D.C. And what we were doing there was developing some technology to measure DNA for essentially clinical diagnostics and forensic applications. After that, I went to the University of Bern, where I worked in the Institute of Clinical Pharmacology. And what I was doing there was developing methods to analyze drugs in people's body for personalized therapy. So that's where you take a drug and we measure the amount of drug that's in your body and adjust it on an individual basis so that you get the perfect and optimum treatment for your particular health status. I spent about a year and a half there, and then I went to perhaps the dark side, as some would call it, but I went and worked in a small company in London called Delta Dot. We were developing new technology to measure molecules that were relevant to chemical warfare agents. And so that was a particularly interesting part of my life because I was out of the academic system, out of university, and we were trying to address a problem with not a lot of money, not a lot of time, and very tight milestones. And so that was a different aspect of science and technology and engineering that I'm really valuable to have had. I then returned to Tasmania in 2004. So that's about 21 years now, and I've been here ever since. And my aim was to develop clinical or handheld technology to measure molecules. So that might be at the home, or that might be out by a river, or it might be an airport. And what I'm really happy about is that I have 4 products are currently available to buy around the world based on the research I've done. And they're pictured in the bottom left of that slide there. So the first one there, the HPC, is just a laboratory instrument, so that has some unique performances. The ETD100 is perhaps our greatest achievement, and that's aimed at detecting homemade explosives within 60 seconds to go into airports. HemaPen, that third one there, is for collecting blood spots at home and sending them to the laboratory for analysis. And the IonQ system there is our latest product, and that's for monitoring waters for nutrients and environmental pollution. So that's a relatively new product and still in the development stages. So again, there's a great team in Melbourne that I work with, around about 30 to 40 people around science and engineering to actually have achieved that. So I think that's enough about me. So I think we're going to hand over now to Amina. So Amina holds a PhD in chemical engineering from the University of Melbourne, where she specialised in capacitive deionisation of water for wastewater treatment. Following her passion for research in the industry, she is now a senior research engineer at Orica. Amina, thank you for joining us.
Hi, everyone. Can you just do a quick sound check? Can you hear me?
Yes, I can hear you fine, Amina.
Okay, fantastic. Yeah, I guess my journey sounded exciting to me, but now that I listen to yours, it's not as exciting. But yeah, it involved definitely some moves around the globe. So my name is Armina. My background is mainly in chemical engineering, and I'm very excited here to share what I have been through in the past, 30 years of education and in different scales. So yeah, the journey may look like a bit of like a straight ladder, but it's never like that. It's often like what I explain it as like a mountain or hiking trail that you just like explore a different way. You sometimes feel like, oh, you're lost. You need a map. You need a GPS, and sometimes you just get to moments that it's just really scenic and are like the wow moments. But obviously, all of those challenges and exciting moments, they all help to shape who I am. So yeah, I started by studying 2 bachelors, chemical engineering and mechanical engineering back home at Polytechnic of Tehran, or it's also called Amirkabir University of Tehran. So I'm originally from Iran. Some people just like can't wait to finish uni or studying. I loved it. I was so hungry to learn, and similar to Michael, maths, any subject that had some sort of calculation, some sort of maths in it was my favorite. So also doing like a double degree helped me. I think I have, the chemical and mechanical engineering helped me actually realize that I like the mech-eng part more, the chem-eng part more, but I used that opportunity to gain some mechanical engineering knowledge and sort of like a lens to my chem-eng degree. I then did like a Master of Science there, and it's sort of like back home, we do it similar to the US structure, that you have 1 year of advanced subjects and 1 year of research, which I did my work on removing of an organic waste in water system. Then after that, I was just keen to apply and do my PhDs. But funny enough, I always wonder what would have happened if I just like decided to enter the industry and follow the path as like a process engineer. Sometimes I feel like, oh, that could be like more exciting, more connected to my chemistry background. But funny enough, I recently talked to a friend, and she took that path. And she was saying, I'm always thinking, what would have happened if I have done more studies or gone into research? So I guess you're always going to have this like lots of different paths in front of you. You're going to pick one based on your like best knowledge at that point. It's always going to be like a winding road. It's not going to be straight, but just like expose yourself and move forward. But if you just want to keep thinking and try to plan everything to the end of that journey, it's not possible unless you have a time machine, which I didn't have. So I moved to Australia, about 12,000 kilometers away from home, hardly knew anyone in this town. But I've traveled to Australia before, and I knew it would be a great place to live. And I knew I'm going to work with like I was planning to work with like a very supportive group, which I'm very fortunate that I had that. So I did my PhD on a different sort of water treatment. This time I was removing salt from low salt concentration waste. For example, it's not suitable for seawater, but it would be suitable, for example, for lake water or low salinities. So as a PhD student, you just like you get deep into one topic, you try to like really focus on that area, but you may not necessarily continue working in that field. But what you need to know is that both as an undergrad or graduate studies, you're learning skills that you're just gaining down the track. It may not necessarily be that particular field of area, but it will be like the critical thinking, the literature review, the research work, the skills and capabilities that you gain through this journey will come handy. Toward the end of my PhD, I was working for a completely different team at our department, working on chocolate emulsions. I was not allowed to taste any, but funny enough, when I moved to Orica, my first task was to work on an explosives emulsion. So I carried along, again, that concept of that chemistry of how emulsions work and how we can check their stability, but for a completely different industry, this time for bulk explosives for mining applications. I moved across different part of Orica. I used to work on our most sensitive part of our products, which are the detonators. And I have been picked up by some of those machines that, Michael, you have developed, that EDT 100, I would say, multiple times at the airport, because even the dust in the lab was getting picked up as I was traveling through the airport. But every time I explained the reason behind it, and I was cleared. I worked across different products. Wireless initiating system was one of the ones that I spent about 3 years on. And I sort of became a bit of a role model in that team as well. You see my pictures at the bottom, holding one of them in front of one of our trucks that deliver the products to site. Then I moved into the research and innovation part of Orica. Again, lots of exciting projects. My previous roles with Orica were more around technologies that were closer to being delivered or have been delivered, but we are sort of like improving on their quality and performance or come up with new ways of using them. As a research and innovation member of the team, I'm sort of like looking to more long-term projects that may not come into commercialization next year or the year after, but they are in the pipeline to gradually get more and more mature. Some of them might still be an incremental change, but some of them, like the one that I'm currently leading, will be a major change into how we extract metals. The tiny picture you see on the right-hand side is my current project. It's called in-place recovery. So if you're familiar with the way, for example, we extract copper, we need lots of copper. If you're talking about renewable energy, we just need to simply just double the copper production to have enough copper for transition lines. So copper is one of the critical metals that we need to expand its production, but it's getting more and more costly to do that. So in this process, we try to extract copper in the ground rather than moving the rocks from the ground and do the processing on the surface. So that's why we call it in-place recovery. Anyway, that's an exciting project. If you're keen to hear more about that, connect with me on LinkedIn. and I'm happy to chat hours and hours on that project. But another thing that I would say, like, it's sort of like hidden in the journey, which I wanted to emphasize, was that element of like, you constantly try to grow in your leadership skills, influence skills, communication skills. And those are the things that you may not easily you may not have taken a subject on them when you were doing your studies. So one comment I would have is that if you ever have a chance to expand your skills in those soft areas, definitely focus on them. But also, I wanted to highlight the value of mentoring. I had amazing mentors on my journey, and I have also had the pleasure to giving back some of those learnings to the younger generation, either the young PhD students through the program that ATSE runs, IMNIS program, or even through the younger additions to our company, Orica. But yeah, it's been a great journey. When I look back, since, I don't know, 2006 when I started uni, 2014 when I moved to Australia, 2018 when I joined Orica. But yeah, it's always been constantly learning and constantly growing. Thanks, Michael.
Thank you, Amina. That was awesome. I mean, I want your career rather than mine. That sounds wonderful, and I love the chocolate emulsion to explosive emulsion connection. That's just blowing my mind at the moment. But more questions for you later, right? So if you have questions for Amina, please put them into the chat. We're going to now move to Vanessa. So Vanessa completed her PhD, a Bachelor of Science, and started her work in a fly-in, fly-out graduate program in a junior gold mining company. She gained practical knowledge and hands-on experience in geochemical laboratories and managed a sample preparation facility, which led her to Australia in 2018. Her recent experience focused on quality management systems for commercial laboratories, involving things like audits and process management and laboratory information management systems. That sounds like a real hoot, Vanessa. I'm sure you're going to tell us how fun that was. And she's now working as a mine site projects coordinator, which involves planning for all aspects for on-site laboratories globally. She received an Elevate Leadership Scholarship in 2023 and started postgraduate studies in extractive metallurgy in 2024. It's going to be great to hear from you, Vanessa.
Thank you very much, Michael, for introduction. It's a pleasure to be here. Hello, everyone. I'm Vanessa. I'd like to start my journey to communicate that I got my Bachelor of Science. I've studied chemistry, and on my final thesis, I actually researched for the antioxidant activity from the leaves, alongside my team that studied antifungal and the other different potential, such as antibacterial. So I thought my research would lead me into a job in like R&D or food industry, for instance. But little less that I know, I end up in a graduate program in a mining industry, which is completely different perspective. If I can get the slides going, please. Thank you. I started off my journey in a graduate program. The graduate program, I want to say, it's not really exclusively offered in the mining industry. A lot of government and private sector, as well with public sector, offer that. It typically run with set amount of time, so say 2 years, where you get a lot of support. So you get training from each different section of the part of the business, and you also get mentorship throughout the process. So I started off with the graduate program. Unfortunately, this my cohort was cut short during the downturn of mine, and then I permanently assigned in the laboratories. What do we do in the mining lab? So it seems like we, in a really, really simple manner, we analyze all of the samples. So the soils, the rocks, and the water samples that are coming from the processing plants. At that time, I worked for the gold mining. So we typically look for gold, but we also look for silver and copper from all of the rock samples. But first thing, before we analyze those rocks and soils, we need to prepare them. So if you imagine about 5 kilos of rocks, we can't really just send that to the lab. So what we do is we grind them, we make sure we crush them, and then we grind them into a fine powder. And these fine powder then get sent to the lab, get weighed, and then we do acid digestion before we read that into the instrument. And at that time, when I used the instrument, it was we're using atomic absorption spectrometer. But I'll walk you through as I learn, as many years the instrumentation has been changed. So it's one of the cool benefit that you get to use this instrument and actually learn how to maintain them. And then I move on to my next role in the exploration company. So it's a little bit a stage before we mine. So in the exploration company, we try to find the deposit. We try to find which ore bodies that has the valuable minerals. So on the first little photo there that looked like a very small green, it's actually my view from the helicopter. So in order to get to the exploration site, this is a very remote place. To get there, there isn't any road, so we have to take helicopter there back and forth and collecting all of these bags of rocks, which then we crush them again, we grind them. We didn't have laboratory in this facility, so my role was to making sure I coordinate with the external laboratories. So I send the samples to the external lab, which then they analyze and send us the result. And I suppose on the second stage, I learned that the role of chemistry, you can contribute it beyond being in a lab. You can also being the connection from the geologists and from the business side of things. And then after a few years there, it's become too remote. It's fly in, fly out can be hard, and it's one of the toughest side I've ever been. I've decided to take a different role, and this is where I joined a service company adjacent to the mining industry. So we analyze the samples. If I can have the slide number 3, please. Thank you. So I established sample preparation hub. Back again, what I said that before we're sending the samples, we need to make sure the samples, the rock, the soils, being crushed properly. We got to make sure they are homogeneous, they are being prepared to the quality, and they are really grind and fine to certain quality. I'm really fortunate because I get the chance to establish the whole facility itself. Being in the first commissioning stage, it's quite rare opportunities, and it really gives a little bit different perspective on a communication. As you can imagine, you're trying to construct a small facility, so it's pretty fun. You get learn a lot beyond the chemistry side of things. This company is a global one, so a big benefit of it that you get opportunity to get transferred throughout their facilities, and that's how I end up in Australia, where I landed in commercial labs. Yeah, the first photo there that looked like orange liquidy, it's a fire assay technique. That's one of the common classical technique where we use to extract the gold and analyze the sample. And next to it, it's a really quite small of test tubes, what it looks like before it gets sent to the instrument. So we're dealing with commercial laboratories. It's a lot of samples every day, lots of volume, but it's very fun. You don't know what you get, and you keep learning every day. After a few years during this process, I've got transferred in the same company to look after the quality of the data. Now, I want to say this is probably so far is very fun role because you deal with lots of R&D, a lot of requests from the customer. So it on the very right side that look like a red, orange, and green, and there's some kind of line in between. That's the data that we produce. Green means good, orange means warning, and red is no good. So if you really like data or look at numbers, look at anomalies, this is really great fun because you look at these kind of data set and pattern and try to make which one that's say oh, this is really biased on one side, or this is really starting to shift it towards the orange zone. So that's how you flag it and try to understand why. So and I look after 3 laboratories at that time. So it's really busy role, but it's really fun. You get to know and get to communicate with a lot of technical team and a lot of chemists and research team from all over the world. Um, Unfortunately, I have to relocate to a small town, and in which I don't really able to maintain with with the job. So I decided to go back to do a fly-in fly-out. However, it's on the different commodities. This is for zinc and lead mine. Zinc we probably heard that the elements they use it for coating the iron to make it not rusty. And lead is you can find it in or hear it a lot in batteries. So it's on the left side is the digest, so we use acid digest. It's quite typical methodology to analyze the samples. And on the right side there, we make a XRF fuse beads. So one of the technique, one of the coolest machine that we use to read the samples, and they will tell us how much lead and zinc in our processing plant. And yeah, but during I do my fly in fly out during my days off. It's I think that's the thing about being fly in fly out. On your days off, you feel like you got a whole week um, free. So I started to think about maybe I should go back to study again. So that's how I look up and started searching for scholarship opportunities, which that's how I landed, and very grateful for getting Elevate scholarship. I'm currently studying extractive metallurgy in Murdoch University. It's been a really fun journey, but at the same time, I also work as a mine site projects coordinator. So we're basically just helping all of the mining's customer globally, and how do they want to make their own laboratories. It's pretty fun because you get to design the lab, so you know you've been in a laboratory before, you've been used all of the parts of it, and now you get to design it to make sure that it's the full plan and all of that makes sense. And it's been great journey.
Thank you, Vanessa. That was a wonderful overview of your journey so far. So I'd really like to bring Vanessa and Amina back so that we can answer some questions. So if you have some questions, please type them in the chat. There's a couple in there already, so I'm going to start with one that I think is all relevant to all three of us from the floor, and that is, was it hard or exciting to move to different countries to continue work and learning? Because I left Australia and have worked in 2 other countries. Vanessa and Amina, I think both of you moved into Australia, right? So what are your thoughts on that moving countries and working and learning? Maybe we'll go to Vanessa first and then Amina.
Yeah, well, when I first started to Australia, I went for training first, so that's quite helpful. But I have to be honest, it's quite a big shock in a bit because all of my English are mostly a little bit more American, and I have to say Australian English is a bit different. So, and then I got assigned to Kalgoorlie, which has a quite a different accent too. So yeah, but I have to say people are really lovely. They're really welcome and really help to for during the first couple of years of coming here. So it's been great.
Amanda, what was your experience like?
Yeah, quite similar. I think I was also lucky that I first moved to a university environment, and that those are usually like quite multicultural and very welcoming too. But I totally agree. Like we usually learn English by textbooks and by watching lots of like American programs, and that's like coming across and like having difficulties trying to even communicate. But the other element I think was like big cultural change, because I think for some people that may move from like one Western culture to another Western culture might find it a bit easier, but when it's like there's also a cultural difference, that's another challenge to overcome. But it's definitely, as I said, it's a part of a challenge that makes it a part of a learning experience. And I've recently been like even expanding that. Came across a really nice book called Cultural Map. I highly recommend that to whoever wants to work with other people across the globe. It's good to understand that not everyone treats time, teamwork, or every other aspects the same. So yeah, I use it as like an opportunity to learn how other people across the globe work and operate, basically.
Yeah, so it's interesting. Some of those correlate really well to my experiences. So I had the privilege to work in America, in Switzerland, and also in England. Two of those are, of course, Western English-speaking country, although American English and Australian are not equivalent. And sometimes you don't use the right word, which can create some very interesting cultural experiences. But Switzerland for me was really interesting because I don't speak any German. And I was in the Swiss German part, and so you know that the culture there is very different, but the isolation of not being able to speak any language at all was really quite confronting, and really quite enabling in terms of integrating into society and the effort that you have to make to actually, you know, just work with your colleagues and talk with your colleagues and socialize with your colleagues. But it was also one of the best things I ever did, was to work in a place where there is that, you know, you have no choice. You have to do it, and you will survive and learn things and be much stronger for that. So thank you for sharing that. I haven't. There's another question from the floor which I'm going to ask because it kind of links all three of us as well. So the question here was specifically for me about being in Tasmania. Is it it's a small state. Is it a good place to go for careers in chemistry, or do I have to travel? But you two also have lots of experiences in small places and working in small places around chemistry and experiences, and some of that might be dealt through with fly in, fly out, and some of it, I think, Amina, I think you're in a small town, just in New South Wales somewhere, I think, from memory. So I'm going to get your thoughts in a minute, but I'll give my answer to that question first. Is that Tasmania is a great place to do everything, really. I'm a Tasmanian, of course, I have to say that. But chemistry is so broad that there are so many opportunities to do a whole range of things, that you're not really restricted on what you learn. And with online learning these days, you can do degrees in a whole heap of areas that feed into and utilize chemistry. And there's a whole heap of local employment options that also feed in and utilize chemistry. And the other thing I'm going to say is that, and maybe this is something else that we can discuss, is your pathway is not necessarily the one you think it will be, and that your career is probably going to define just as much by what you plan to do as much as the opportunities that will be presented to you along the way. Let's go to Amina first this time. What are your thoughts on small places, and can you get the education and experiences from there?
Yeah, for me it was a bit of like sort of like the opposite. I came from a very, very big town. Like Tehran is a very populated town, and I moved to Melbourne. I even found Melbourne quiet. Then I moved to Newcastle. I found Newcastle even quieter. Then I moved to Toowoomba, which I would definitely put it under like the small town category. But I think you just realize that but if you're enjoying what you're doing, the location is not like limiting you. As you said, these days we are all like, even sometimes we are having meetings with colleagues that are a few doors down the track online, because it's just easier to share a screen and share data over a computer than in person. So I don't think these days that location is acting as a boundary anymore. But definitely, if you are in a smaller town looking for opportunities, every now and then attend some in-person gatherings, maybe involves a bit of traveling or a bit of driving. But it's good to have a good mixture of like that desktop and accessing everything online, and a good mix of that in-person gathering, because that really like helps you to build your network. So I've been trying to have a mix of both. Sometimes I need to travel. Sometimes I just need to do it more online, have video calls on to establish that connection. But yeah, I don't think these days the location is a boundary anymore. But I like the fact that you refer to Newcastle as a small town, because I say this to local people and they don't agree with me.
Thank you, Amina. Vanessa, what are your thoughts?
Well, I suppose I've relocated quite a bit, and I want to say Kalgoorlie is quite a remote place. It's the closest large town is about 800 kilometers, but it's also one of the home of the schools of mine. So one of the famous one. So I think education in a smaller town, especially with these days university offer hybrid mode and such, it really helps the student enroll places. I want to also share, I live in Ingham, which I think Amina would be a bit shocked. It's a 4,000 people kind of town, probably just like a suburb. It is probably like a suburb in Jakarta where I come from. So, but that's a whole town. And with the chemistry degree, you can actually work in the sugar industry, which is one of their main employment for the people locally. So it's I think really if we are open for opportunities and really just take a chance with what's available, I think that's an open door to many great things.
Cool, thank you, Vanessa. So there was a question there, as a rural student, what can you do to get a head start in chemistry? I think we may have just answered that question for you. The fact that you're here in the first place engaging in this type of forum is a really great start. And you've just heard Vanessa and Amina talk about some of the opportunities that you actually can get, and they may even be better opportunities by simply being in a small place. And you talk about your 4,000. Well, I'll raise you that the town I grew up in was about 500 people. So I think I win the smallest one at the moment.
Yes, I think you won this.
Yeah. Look, this has been great, but unfortunately, we do need to wind it up now. And so I want to thank Vanessa and Amina for all of their wonderful insights today. I hope you've all joined, and I'm going to hand back now to Alejandra to wind up.
Thank you so much, Michael. And I am just going to join the group of small cities. I'm currently based in Canberra, and I really loved what Armina said about like your location doesn't matter when you're enjoying what you're doing. I'm currently working in science policy, and I love Canberra, even though that it has such a bad rep in Australia. Anyway, thank you so much, Michael, for your time and amazing contribution to today's session. And thank you once again to Armina and Vanessa. It was so inspiring to hear your career journeys, and what a great discussion for an audience. Thank you also to all of you in classrooms and offices who have joined today. We hope that you have something to take away from this session that has left you with a better idea of how many different careers you can pursue in chemistry. Please join us for our next Shape Your Future on June 11th, where we will be celebrating World Ocean Day with Dr. Alistair Hobday, presenting live at sea from Research Vessel Investigator. Thank you for joining us, and see you next time.